Welcome to the presentation on infection prevention and control requirements during construction, renovation, and maintenance projects. Throughout this presentation, the term patient will be used to refer broadly to individuals receiving care, including clients in outpatient and community settings, as well as residents of long-term care facilities. Today's presentation will cover IPC practices required when working within healthcare facilities, guiding documents that support CRM projects, roles and responsibilities of key stakeholders involved in CRM, risk assessment, including sources of contamination and remediation practices. We will review the Infection Control Risk Assessment, also known as an ICRA, including how to determine population risk group, construction activity types, and how to use the ICRA matrix to identify required preventative measures. Key preventative measures and hoarding requirements will be reviewed, along with real-world examples of do's and don'ts observed on active construction sites across the region. This session will conclude with scenario-based learning and a QR code to track completion of this education. These scenarios will be better understood if the ICRA is used. The ICRA file is available on the IERHA Infection Control page in the CRMD Education folder. You can pause the presentation and access the file now or print a hard copy. IERHA is committed to preventing infections that may pose serious risks to patients, staff, and visitors. Everyone working within our facilities is expected to follow established infection prevention and control standards, protocols, and practices aimed at identifying and minimizing the risks of infection transmission in healthcare environments. General IPC practices all workers must follow include performing hand hygiene at appropriate times, such as when entering or leaving a healthcare area, after using the washroom, or after blowing your nose. Workers should stay home when ill and practice proper respiratory etiquette, including covering coughs and sneezes to reduce the spread of germs. Personal protective equipment, PPE, must be worn as required. Keeping vaccinations up to date is also essential, as immunizations provide important protection against many infectious diseases. Workers must be familiar with the standard operating procedure for infection prevention and control during construction, renovation, and maintenance projects, as well as any other documents and standards relevant to the work. This includes applicable CSA standards, shared health CRMD documentation, and Safe Work Manitoba resources. Construction, renovation, and maintenance activities can create conditions that significantly increase the risk of infection, potentially resulting in serious health impacts for patients, staff, and visitors. Without proper precautions, even small amounts of microorganisms released during CRM work can lead to severe illness. During these activities, contaminants may spread through the air, water systems, workers' clothing, and construction materials that are improperly transported or stored. Contamination during construction can result from several factors, including poor planning or insufficient site preparation. These issues may lead to inadequate or uncontrolled ventilation, improper or insufficient containment of construction activities, improper storage of construction materials, ineffective removal of construction debris, or inadequate cleaning practices. Construction work can disturb existing contaminated materials and generate dust. If these contaminants are not properly contained within the construction area, they can spread beyond the work zone, settle on patient care equipment and supplies, and increase the risk of infection. Water presents a significant risk during construction, as materials exposed to moisture or dust can become quickly contaminated. Standing or stagnant water, as well as plumbing activities, may release contaminants that can compromise the facility's water supply. Mold is commonly encountered during construction in healthcare settings. Moisture, the primary driver of mold growth, can originate from multiple sources, including plumbing leaks, condensation, flooding, or elevated humidity. When moisture and air are present, Mold can grow on most organic materials across a wide range of temperatures. Because mold growth can begin developing within 48 hours, all water leaks or moisture events must be addressed promptly and IPC notified immediately. Depending on the extent of the contamination, a formal remediation and abatement plan may be required to safely address affected areas and prevent further spread. Water or moisture damage may also result from improper transport or storage of materials, inadequate environmental controls, or undetected plumbing leaks. Photo 1 illustrates an undetected water leak in a community clinic. Photo 2 shows unwrapped supplies being delivered to a new build. Photo 3 depicts unwrapped drywall stored at a job site with uncontrolled humidity. Abatement activities in healthcare settings may involve asbestos or mold and require comprehensive abatement plans with strict controls to ensure patient, staff, and visitor safety. Safe Work Manitoba guidelines must be followed. For infection prevention and control purposes, these requirements are in addition to any control measures identified through the Infection Control Risk Assessment. Regional workplace health and safety must be involved in the planning and review of asbestos abatement activities. Occupational health and safety must be notified immediately in the event of any actual or suspected exposure. An infection control risk assessment must be completed early in the planning phase before any construction or renovation activities begin. What is an ICRA? An ICRA is a structured process used in healthcare settings to identify, assess, and mitigate infection risks associated with activities that may expose patients, staff, or visitors to infectious hazards. Its primary purpose is to prioritize patient safety, particularly during construction, renovation, maintenance, or other activities that may disrupt the environment or impact air and water systems. The ICRA defines the scope of work and identifies impacted systems, the population group at risk, the type and invasiveness of the construction activity, and the preventative measure required for the project. Who completes the ICRA? For projects requiring preventative measures 1 or 2, the ICRA may be completed by capital planning or facilities management. At a minimum, the assessment must identify the at-risk population, construction type, and selected preventative measures. For CRM projects requiring preventative measures 3 or 4, the ICRA must be completed by the Infection Prevention and Control Team in collaboration with the multidisciplinary team. Why is it important? The ICRA clearly identifies the infection prevention measures that must be implemented to protect patients and reduce the risk of healthcare-associated infections during the project. The level of preventative measures required increases with the vulnerability of the patient population in the area where the CRM project occurs. Population risk groups are arranged on a graduated scale, with risk group 1 representing the lowest risk and risk group 4 the highest. When a project affects more than one risk group or spans multiple geographic areas, the highest applicable risk group must be used to determine the required preventative measures. This ensures that the most vulnerable patients remain protected, even if only a portion of the project impacts them. Consideration must also be given to adjacent units, as nearby areas may be indirectly affected by construction activities. Construction activities are classified by their level of invasiveness and potential impact. Type A represents the least invasive activities. These include non-intrusive tasks such as visual inspections, routine maintenance, and minor repairs that do not generate dust, noise, or vibration. Containment measures or service interruptions are typically not required. Type B includes activities that are slightly more disruptive than Type A. These tasks involve light construction work that produces limited dust or noise and require minimal precautions to protect nearby areas. Type C involves a moderate level of disruption. These activities often generate noticeable dust, noise, or vibration and may require temporary barriers, partial service shutdowns, or enhanced protective measures. Type D represents the most invasive category. It includes major construction or demolition activities that produce high levels of dust and debris, result in significant service interruptions, and pose the greatest risk to building systems, occupants, and ongoing operations. Using the ICRA matrix shown on this slide, align the population risk group with the construction activity type based on the project scope of work to determine the overall project classification level. This classification identifies the preventative measures required to safely carry out the work while minimizing risks to patients, staff, and others in the surrounding areas. This slide outlines the key requirements for preventative measures 1 through 4. Note that the requirements are cumulative. Each higher level includes all the measures from the previous levels in addition to any new ones. For preventative measures 1, here are the requirements for each stage of construction. Before construction, the area gets a pre-construction clean. Potential service disruptions like water or HVAC issues are identified, and any high-risk patients are identified who might be affected and are moved to a safe location. During construction, the contractor works to keep dust to a minimum, closes access panels right away, replaces any tiles that get moved, and cleans the space using a HEPA vacuum. After construction, there is a review to make sure all preventative measures were followed and were effective. For a preventative measures 2 project, imagine something like sanding a small section of wall in an outpatient clinic. Before construction, safe routes are set up for workers, waste, and supplies. Any penetrations, windows, doors, or other potential air leaks are sealed, and drop sheets are put in place to contain debris. At minimum, a single layer of 6mm poly is installed from floor to ceiling with all edges and joints sealed, supported with zip poles or framing as needed. Ceiling tiles are either protected with a poly barrier or cleaned with a HEPA vacuum once the dust generating work is done. During construction, dust is controlled by misting surfaces while cutting. A walk-off mat is placed outside the work area entrance, and any debris or dust is captured with a HEPA vac attachment. The area is cleaned daily using a HEPA vacuum or wet mop, and all debris and equipment are transported in covered containers with wheels wiped clean. After preventative measure 2 construction, make sure the ventilation system is working properly in both the construction area and nearby spaces. Confirm that the construction area has been thoroughly cleaned and report any discolored water or leaks immediately. And remember, all preventative measure 1 requirements still apply to preventative measure 2 projects. The CSA images show what your barrier should look like. Figure F3 shows a single layer of poly going up to the false ceiling, covering the ceiling tiles with a walk-off mat and tape seal around the perimeter. Figure F2 shows an acceptable design for a double flap poly door, which is required for preventative measure 2 projects. For a preventative measure 3 project, think of something like removing flooring from a resident room in a long-term care home. Before construction, the multidisciplinary team meets to decide on the appropriate IPC measures and review any potential service disruptions. Dust barriers are set up from the floor to the underside of the deck or true ceiling using 2 layers of 6mm poly plus a protective gypsum wallboard layer. Surfaces closest to the patient zone must be wipeable. Modular wall panels or temporary containment vessels can be used if approved by the MDT. The facility's permanent ventilation system in the construction area is turned off and all duct openings are sealed until the project is finished. The construction air handling unit, CAHU, used must meet CSA standards, exhaust air directly outside away from intake vents, and filter air through a HEPA filter. A manometer is installed 5 meters from the construction entrance on the adjacent or exterior side of the dust barrier to provide continuous audible or visual alarms and must remain calibrated at all times. Preventative Measure 3 projects also require a hollow metal, non-combustible door and frame that's lockable with a door closure, tack strip at the bottom, and weather stripping around the frame. The double-layer poly barrier has lap joints, and the entire perimeter, floor, and ceiling is continuously taped. Any penetrations through the poly are sealed on both sides. And remember, all Preventative Measure 1 and Preventative Measure 2 requirements still apply for Preventative Measure 3 projects. During construction, record the daily inspection of the CAHU. Check temporary flexible ducts each day for leaks or damage. Keep a monitoring device running that constantly shows the pressure difference between the construction area and occupied spaces and record it at least once daily. Clean the construction site and adjacent areas daily. Let the MDT know immediately if the scope of work changes. After construction, the hoarding stays in place until the project is fully finished and the area has been thoroughly cleaned and inspected. The CAHU continues to run until air clearance is achieved. The constructor performs a post-construction clean. IP&C inspects the area to approve hoarding removal. Hoarding is never removed before inspection. When removing hoarding, minimize dust and debris by using HEPA vacuums, damp wipes, and carefully rolling in the construction side poly. EVS completes a terminal clean. Make sure the facility's permanent ventilation system is fully operational and cleaned if contaminated. Flush the water system and follow any disinfection procedures as determined by the MDT. Figure F3 and F5 from the CSA standards Z317 detail hoarding construction and barrier detail. These documents should always be reviewed prior to construction to ensure requirements are met. Preventative Measure 4. Before construction. Construct an anteroom using doors equipped with closure system. Anteroom should be large enough that material can pass through without both doors being open at the same time. Metal studs are 400 millimeters on center with 2 layers of 6 mil poly on one face of the studs, sealed and protected with drywall with wipeable surface on hospital side from floor to true ceiling. Exit procedures must be posted. Place walk-off mat outside and inside all anterooms in the direction of dirty side to clean side. During construction, follow all Preventative Measure 1 to 3 requirements in addition to ensuring entry to the construction area is through the outside of the building or through the anteroom. Workers must vacuum clothing with a dedicated HEPA vac in the anteroom before exiting or follow appropriate PPE procedures before entering patient care areas. Take a look at the images highlighting Preventative Measure 4 barriers. The anteroom should have a dedicated HEPA vac and follow proper exit procedures. It needs to be large enough so materials can be brought in while keeping only one door open at a time to maintain pressure. Pay attention to placement of the walk-off mat and the manometer setup as well. The do's and don'ts of CRM. Is your hoarding effective? In the first set of pictures, the hoarding has a thick barrier that is properly sealed. In contrast, the second set of pictures shows plastic that is not fully sealed, allowing dust to escape from the job site and making it ineffective for adequate dust control. Is your walk-off mat capturing dust and debris? We see some examples of ineffective walk-off mats in the images shown. If you are in a period of heavy demolition or workers are not following exit procedures, mats will quickly lose tackiness. Ensure you are changing them often to prevent dust from escaping from the job site. Is your CAHU meeting CSA standards? Is it clean? Has it been leak tested? Was it transported and stored appropriately? Is it working effectively with filters in place and checked daily? Leak testing and calibration should be done prior to project onset and when filters are changed. A verification sticker with details should be clearly visible on the unit. A filter replacement may be required if the unit fails testing, the filter is damaged, or when negative pressure is affected. Exhaust CRM air outdoors through a HEPA filter and away from any air intakes. A key concern for Preventative Measure 3 and Preventative Measure 4 projects is air pressure management. The construction zone must be kept under negative pressure relative to the adjacent areas to prevent contaminated air from escaping. If pressure is not maintained, dust and pathogens may migrate into patient care environments, increasing the risk of healthcare-associated infections. Continuous monitoring, alarms, and documentation of pressure differentials are essential to detect and correct any failures promptly. Negative pressure must be maintained at negative 7.5 pascals or negative 0.03 inches water column within the construction zone relative to the adjacent healthcare area. Use the IERHA CAHU Daily Pressure Differential Monitoring Form and CAHU Monitoring Form for these projects. Note that the Magna Helix manometers are not to be used as they are not capable of continuous monitoring of the job site during off hours. Do you know how to access ceiling spaces appropriately? Preventative measures are necessary during ceiling access because disturbing ceiling spaces, even for short and minor tasks, can release dust and contaminants that pose infection risks, especially in healthcare settings. Reach out to IPC before you begin work to discuss the scope and the risk group for the area. Are you keeping the work site tidy on a daily basis? Have you done a thorough post-construction clean? Construction cleaning is an ongoing process of cleaning that happens throughout a construction project, not just at the end. Its main goals are to keep the site clean on a day-to-day basis through scheduled daily cleanups, prevent dust and debris from building up in fixtures, ceilings, service spaces, and other hidden or enclosed areas. By making cleanliness a continuous part of construction rather than a final step, we greatly reduce risks from dust, debris, and contamination, creating a safer, more compliant work environment. Daily cleaning practices include removing dust and debris with damp mopping and HEPA-filtered vacuuming. Dry sweeping should be avoided to limit airborne particles. Wiping all surfaces, ledges, fixtures, and hidden areas, including ceilings, ducts, and spaces behind hoarding. Keeping waste bins covered and emptied daily. Performing more frequent cleaning during active CRM projects to maintain a safe, controlled environment. Now that we've reviewed the process, let's practice with a few scenarios. In each example, think about two key questions. One, what is the population risk group for the area where the work is happening? And two, what type of construction or maintenance activity is being done? Once you have those answers, you can determine which preventative measures are required. If you haven't already done so, pause the presentation and pull up the ICRA that was sent with the link to this presentation to assist you in working through these scenarios. Scenario 1. Facility maintenance is scheduled to repair a grab bar in a patient's washroom on a surgical unit. The scope of work includes patching and painting the wall. Determine what preventative measures are required. Based on the risk assessment, this project involves sanding a small section of wall for repairs. This activity falls under Type B construction classification. According to the risk assessment, a general surgical unit is classified as Population Risk Group 3, which represents a medium to high risk category. The population risk group is classified as 3, and the risk assessment for the project is identified as Type B. Based on these factors, the overall project level is determined to be 3. Hoarding with negative pressure will be required. An external contractor has been hired to complete an extensive renovation of an outpatient oncology department including new drywall and flooring. What preventative measures are required? Based on the scope of work, it is classified as Type C construction activity. According to the risk assessment, an outpatient oncology department is classified as Population Risk Group 4, which represents a high-risk area. The construction activity is classified as Type C, and the population risk group is a 4. When combined, this results in preventative measures 4. Therefore, all preventative measures 1 to 4 must be implemented, including hoarding, negative pressure, and an anteroom. Scenario 3. Facility maintenance is replacing a leaking sink in an outpatient area after hours. What preventative measures are required? This project involves minor plumbing work that interrupts water service to a localized client care area for under 15 minutes, classifying it as a Type A construction activity. Outpatient departments, when accessed after hours, are classified as Population Risk Group 2. Since the construction activity is classified as a Type A and the population risk group is a 2, the project is a designated Preventative Measures 2. If you were unsure where to find information related to what preventative measure is required for the project you are working on, what resources could you use? All of the options listed are excellent resources to find out more details and ensure you are following preventative measure requirements for your project. The key takeaway from this presentation is to recognize the critical importance of following IPC preventative measures. Construction, maintenance, and renovation projects in healthcare facilities pose significant infection risks if dust and airborne contaminants are not properly contained. Thank you for listening to our presentation. Please complete the link to MS Forms to record your completion of this education session.